Imagine this: NASA's Europa Clipper spacecraft, currently cruising towards Jupiter, is about to get a surprise shower of particles from an interstellar visitor. That's right, a comet from beyond our own solar system, named 3I Atlas, might soon pepper the probe with charged particles from its tail. This isn't science fiction. It's a prediction from two European researchers, Samuel Grant and Raint Jones, who've developed a clever computer program called Tailcatcher. So, what does this mean? Is the multi-billion-dollar spacecraft in danger? Absolutely not. This event is completely harmless. In fact, it's an incredible stroke of luck. It provides a once-in-a-lifetime opportunity to directly sample material from a comet that originated in a completely different star system. Think about it. We could get a taste of another part of our galaxy without ever leaving our cosmic neighborhood, as Samuel Grant explained. We have almost no data on what interstellar comets are made of or the star systems they come from. Sampling this comet's tail is the closest we can get to analyzing one of these mysterious objects. Now, how does this work? Comets are essentially icy snowballs that release gas and dust as they get closer to the sun. This creates the tails. The one we usually see, the bright dust tail, follows the comet's path. But there's another, less visible tail called the ion tail. This tail is made of charged particles, or ions, that are blown away from the comet by the solar wind, the constant stream of particles flowing out from the sun. Because the solar wind radiates outwards, the ion tail always points directly away from the sun. This is where the magic happens between October 30th and November 6th. A perfect alignment is predicted. The Sun, Comet 3I ATLAS, and the Europa Clipper spacecraft will form a straight line. The solar wind will flow past the comet, pick up some of its ions, and carry them directly towards Europa Clipper at hundreds of miles per second. Grant and Jones's Tailcatcher program tracked these packets of solar wind to predict this exact moment. Of course, there's a potential snag. For this to work, Europa Clipper's instruments need to be turned on. But the spacecraft is in cruise mode, and not everything is active. Worse, a potential US government shutdown could throw a wrench in the works. If the shutdown isn't resolved in time, scientists might not be able to awaken the necessary instruments to capture this precious data. It's a race against the clock and bureaucracy. If they can make the measurements, how will they know which particles are from the comet and which are just from the sun? Scientists can tell them apart by their chemical makeup. The solar wind is mostly protons and helium, but the material from the comet will contain heavier stuff, like water group ions. Plus, when the solar wind picks up this extra material, it actually slows down and changes direction slightly, giving another clue that it has encountered the comet. This isn't just about collecting space dust. Comets are like time capsules, holding pristine material from when their home star systems formed billions of years ago. By analyzing the particles from 3I ATLAS, we can compare them to comets from our own solar system and learn incredible new things about the galaxy we live in. It's a fantastic and planned science opportunity. Let's hope everything aligns both in space and on the ground, so we don't miss it. Thanks for watching. If you love space and exploration, be sure to hit that subscribe button and ring the bell so you don't miss our next video. See you next time.